Hello everyone, I am a service engineer of SANY Electric Heavy Trucks. Today, I'm going to share with you some energy-saving driving skills for SANY Electric Heavy Trucks. Similar to fuel diesel vehicles, electric vehicles also need energy-saving driving skills. Energy-saving driving is a complicated systematic operation related to drivers, vehicle, and road conditions. Drivers' vehicle control skills are essential to energy consumption of the vehicle. Drivers shall minimize the energy consumption to realize safe and energy-saving operation. Up to 30% of the energy consumption of a vehicle can be affected by driving habits. The energy-saving driving skills are a kind of energy-saving method featuring the lowest cost and the fastest and relatively obvious effect. Now, I will share with you our energy-efficient driving skills from the following perspectives. 1. Smooth start. At the time of starting an electric vehicle, the larger the accelerator opening, the faster the vehicle speed increases. Power consumption is proportional to acceleration. The faster the acceleration, the greater the power consumption. Therefore, smooth start is required as possible. That is, gently depress the accelerator pedal and properly control the accelerator opening. By gently depressing the accelerator pedal and properly controlling the accelerator opening, the power consumption can be greatly reduced, although the acceleration is sacrificed to a certain extent. At the time of start, it is necessary to overcome the acceleration resistance caused by motion inertia of the vehicle. If the driver can gently press the accelerator pedal to moderately increase the vehicle's speed, the acceleration resistance caused by the vehicle can be reduced effectively. Specifically, gently depress the accelerator pedal to about 50%, so that the vehicle can move slowly. It is recommended to control the power below 200 kilowatts by viewing the instrument. Mastering the driving skills to start the vehicle is essential to the power consumption of an electric vehicle. For energy conservation and safety, please do not start running the vehicle too fast. 2. Driving at a steady speed. For the energy-saving operation, like the fuel diesel vehicles, electric vehicle running at a steady speed is also recommended. Moreover, do not change the accelerator opening too much for the purpose of safety and energy consumption. Upon the starting acceleration, properly control the motor speed according to actual road conditions. Use the accelerator to gently and steadily control the vehicle. Do not always rely on depressing the accelerator pedal to keep the vehicle running. For driving at a steady speed, keep the power indicated in the instrument below 200 kilowatts as possible. Do not accelerate and brake the vehicle frequently. Try to keep the vehicle running at a high speed with the engine at a low speed, to achieve a state of steady speed and power balance, thereby maximizing the energy-saving effect. Moreover, properly controlling the maximum speed is also required. The higher the vehicle speed, the greater the power consumption. Generally, assuming the same tire diameter and gear speed ratio, the vehicle model with a greater rear axle speed ratio has an energy-saving driving speed lower than that with a smaller rear axle speed ratio. SANY Electric Heavy Truck High Roof Model has an energy-saving driving speed range of 50 to 70 km an hour. SANY Electric Heavy Truck Flat Roof Model has an energy-saving driving speed range of 45 to 60 km an hour. 3. Vehicle acceleration. Drivers shall slowly accelerate the vehicle by gradually increasing the accelerator opening and preferably keeping this opening in a range of 1/3 to 2/3. When gradually increasing the accelerator opening, control the driving motor power below 200 kilowatts by viewing the instrument. The lower the operating power, the smaller the power consumption per 100 kilometers. During vehicle accelerates, if driver presses the accelerator pedal too intensely, that not only the power consumption is increased, also there is a risk of accident. Too intense vehicle acceleration will cause excessive torque generated by motors, resulting in excessive power consumed in the circuits of the HV system, so that the power consumption is increased. Braking energy recovery. Energy recovery is the main feature to distinguish fuel-powered vehicles from electric vehicles. The motor driving process is a process of power battery discharging and vehicle power consumption. The motor braking and vehicle retarding braking process is a process of charging the power battery by the motor. Therefore, properly realizing the braking energy recovery is essential to the economical operation. For electric vehicles, The energy recovery operation is divided into the following two types. 1. Braking energy recovery. Electric retarder energy recovery. During the braking process, the battery is charged by the motor and the mechanical brake acts at the same time. The mechanical brake mainly relies on the friction of brake pads and the friction of tires to brake the vehicle. Both of these two frictions are subject to heat generation and dissipation. The shorter the braking time, the shorter motor operating time, the less energy recovery quantity, and the greater heat dissipation loss. Therefore, try to avoid emergency braking and rapid deceleration on the premise of ensuring safety. But try to gently depress the brake pedal so that the energy recovery effect can be maximized. When an ordinary vehicle is running in urban areas, the energy dissipated by braking operation accounts for 40 to 50% of the total driving energy. The energy dissipation quantity is increased in case of short range and downhill braking operations. Effectively controlling the braking energy recovery can generally extend the vehicle mileage by 15% to 20%. 2. Electric retarder energy recovery. For the electric retarder, similar to the liquid retarder of a fuel-powered vehicle, primarily the motor's reverse towing operation is utilized to convert power or potential energy into electric energy. Therefore, the electric energy is stored in the battery as internal energy. There are two ways of electric retarder energy recovery. By vehicle models, the electric retarder energy recovery is divided into the column shift lever control mode and the cruise button control mode. 2.1 Column shift lever control of energy recovery. The multi-level energy recovery column shift lever is located here. The level of energy recovery can be displayed on the instrument. Only when the vehicle is ready and the vehicle's speed outnumbers 5 km per hour, such level can be adjusted. The default level of the coasting energy recovery depends on the current position of the column shift lever. Level 1 is at the topmost position. Level 5 is at the bottommost position. Push the lever down to increase the energy recovery level up to 5. Push the lever up to decrease the energy recovery level down to 0. There is a setting key at the right side of the steering wheel. The current default energy recovery level is 2. When the vehicle is started and the vehicle's speed outnumbers 5 miles per hour, it is ready for the up adjustment for energy recovery. The up adjustment is to increase the energy recovery. The down adjustment is to decrease the energy recovery. By vehicle models, the energy recovery is divided into 5 levels and 9 levels respectively. The 5 levels of energy recovery are adjusted by gear shift lever. The 9 levels of energy recovery are adjusted by roller.